Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. In today's lecture, we will study about surface area and volumes, right? You have studied about various figures. For example, a rectangle, you know how to calculate the area of a rectangle, area of a circle and area of various other geometrical shapes, right? But today we will learn about calculating the surface areas of solid shapes. For example, a box, right? Let us say a box is cuboidal in shape, okay, and this is the shape that I am talking about here, right? This is a cuboidal box. Now, if you look at this box carefully, it has got 6 faces, 1, 2, 3, top and bottom, and then this back and front, right? Now, you should be able to visualize yourself, right, that there are 6 faces on this, 6 faces. Even if you look at the room that you are sitting in, there are 4 faces, the 4 walls around you, right, and one is the floor and another face is the ceiling. So, you have got 6 faces in a cuboidal shape, right. So, we have got 6 faces, and if you want to calculate the number of edges, every face, these are 4 edges, right. So, this face has got 4 edges. Now, similarly, you will have 4 edges for this face, whereas this one is common to this face and this face. So, now if you want to calculate the total number of edges, it will be 1, 2, 3, 4 and then 4 vertical. Look at the room, okay. First you look at the ceiling, you have got 4 edges, right, and then look at the height. So, 4 edges again and 4 on the floor. So, 12 edges are there, right. And if I need to talk about the vertices, how many vertices are there? So, these are 8 total vertices, right. Now, we have got an empirical formula for this also. Number of faces plus number of vertices is equal to number of edges plus 2. So, this is an empirical formula for this also. Number of faces 6, number of vertices 8, number of edges 12 plus 2. So, it satisfies this equation, right. Now, I will talk about surface area of cuboid and a cube, okay. What is the difference between a cuboid and a cube? In a cube, all the length, breadth and heights are same, right. So, this is a cuboid that I have made here, and let me make a cube for you. A cube would look like this, where all the edges are of equal length, right. So, if this is A, this will also be A and this will also be A. Now, this is my length, this is breadth and this is height. In this case, this is length, this is breadth and this is height, right. So, if we look at the cuboid first, right, look at the floor or the bottom face. Bottom face that we can observe in our room also is rectangular in shape, right. In case of a cubic room, it might be square in shape. In both the cases, we can calculate the area of the floor or the bottom face by multiplying length with breadth, right. So, in this case, the area of the floor is L into B, and in this case where the floor is square in shape, it is A into A, that is A square, right. Now, look at the ceiling. If the room is cuboidal, the ceiling will have the same dimensions as the floor, right, because if this is L, this will also be L and this will also be B, and it is rectangular in shape. So, the area is same L into B. Now, if I want to combine the areas of top and bottom, I will say 2LB, right. Rest of the faces are lateral faces, right. So, if I want to calculate the lateral area, I will calculate the areas of these lateral faces. Out of them, this front face has got the dimensions L and H, right. So, this front face will give me area of L into H. Similarly, the back face will give me the same area, right, and this face here will give me the area twice of B into H, this and this combined, right. So, I hope you are able to visualize here. In case of a cube, every face will give you an area of A square, because length, breadth and height all are same, right. So, surface area, or we can say total surface area of a cuboid with dimensions L, B and H, right, will be twice of LB plus BH plus HL. So, this is the total surface area of a cuboidal shape or cuboidal room, cuboidal box, anything. Now, if that box, let us look at the sum of the variations. If this box is open at the top, so there is no surface at the top, then we will calculate the area of the rest of the faces. So, we will not consider this L into B then, right. So, total surface area of a cuboidal box open at the top and dimensions are same L, B and H, right. Now, if it is open at the top surface had an area of L into B. So, out of this we do not consider one L into B. So, the area will be L into B for the bottom surface, because it is not open at the bottom, right, plus the lateral surface area. What was the lateral surface area? It consisted of these faces. So, the lateral surface area is twice of BH plus HL, or we can write it in neat form by taking H common, twice of H B plus L. So, this is the surface area of a cuboidal box if the top is open. Similarly, we may have a box which does not have a bottom surface, right, then we will subtract L and B, L into B, right. So, this is about the variations. We will look at various variations when we are solving the questions, right. We will decide there and then which surface we have to consider and which we do not, okay. Now, in case of a cube, total surface area of a cube is, how many faces are there? 6, and one face has got an area of A square, where the dimension or the side length or the length of the edge is A. We can say with dimension A or we can say with edge A. We do not have to mention other two dimensions, because all the dimensions are same, right. So, the total surface area of a cube is 6A square. When, if let us say one of the surfaces is missing, then the surface area will become 5A square, right. We will not consider that face that is missing. If two faces are missing, the surface area will become 4A square, right. Okay. So, this was about the introduction to surface areas of a cube and a cuboid.